Titled Forecasting Bank Failures and Stress Testing, a Machine Learning Approach. This is again co-authored by me, Dr. Papadimitriou, and Anna Grapetidou, and it was published in the International Journal of Forecasting earlier this year. This paper is currently the state-of-the-art in forecasting default risk. The sample we use consists of 443 US banks. These include all 468 failed banks in the period from 2003 to 2013. And the methodology we use in this paper comes from the area of machine learning, and more specifically, we employ a support vector machines methodology. In this setting now, we use 36 variables for each bank. These are collected for a 4-year time window, yielding a data set of 144 variables for each bank. To select the most informative ones from this list of available variables, we use local learning, a technique for high-dimensional data, and then the input set is further refined using a shrinking procedure. The final selected variables in our optimum forecasting model are only 2. We end up with a surprisingly parsimonious model, and these variables are Tier 1 core risk-based capital over total assets for year T-1, and total interest expense over total interest income for year T-1. In this paper, of course, we produce out-of-sample forecasts. This means that the forecasted banks were never before seen by our optimal model, and the results are summarized in this table. As you can see, for the 1,164 real solvent banks, the forecasting accuracy is 99.4%, while for the 115 failed banks during this period, the forecasting accuracy is 97.39%. Thus, the overall accuracy of our optimal model is 99.21%. Next, we increased the forecasting window from 1 year ahead to 2 and 3 years ahead. The model predicted correctly 87.70% of the banks 2 years ahead, and 79.59% correctly 3 years ahead, which is very impressive, at least to us, with only 2 variables. But we did not stop there. In the 1 year ahead forecast, as you can see in the table, we missed 10 banks. We tried to find why we misclassified these 10 banks. The solvent ones that were misclassified as failed, there was some solvent banks that our model misclassified them as failed, and these were 7 banks. After close examination of these banks, we found that they had all received enforcement action from the Federal Deposit Insurance Corporation, and one of them received financial help from the US Treasury as part of the Troubled Asset Relief Program. These findings mean that without this intervention by the regulators at the time, these banks would probably have failed as they were predicted by our model. Now, the failed banks, on the other hand, that were misclassified as solvent, we classified them as solvent, but they actually failed. These were only 3. From a close examination of these 3 banks, we found that one was discovered with unreported losses and was closed for fraud. So it was impossible, of course, to predict its failure from the fraudulent financial statements it provided to the Federal Deposit Insurance Corporation, and we used for our predicting paper. And finally, the 2 other failed banks that we missed, they were both very small banks with total assets of $43.5 and $24.8 million respectively. In this figure, I provide a graphical representation of these results. The dashed line is the classification boundary that separates on the right the solvent banks that are marked with dark gray color from the failed banks that are on the left side and are marked with light gray and they are on the left. With black dots, you see there are 10 black dots. These are the banks that we missed. some solvents that classified as failed, and some that failed and we classified them as solvent.